You have your college education or a coding boot camp, and that's your vector database of knowledge, right? And it's all nice and structured from your coursework and your tests and everything else like that. And then there's everything you learn on the job, and that's episodic memory. And that's primarily what we're focusing on.
Hi everyone, I'm Taqi Jaffri, a lead product for UiPath Enterprise Agents, and I'm joined here today by Scott Florentino, one of the engineers working on agents. Welcome, Scott.
Taqi, thanks for having me.
Okay, Scott, so why don't you walk us through all the different areas you work on?
Sure, so I lead agents online reliability at UiPath. That's primarily comprised of evaluations, simulations, and memory.
Wonderful, it'll be an exciting chat. So let's start with evals. So what are evals and why should we evaluate agents?
Yeah, so evals are test cases for your agent. And testing in software has been around since its inception. And evals are just the next evolution of that. Evals are a way to verify your agent's results as well as the steps it took to get there. I think they differ a little bit from regular software testing because rather than doing exact matching, agents are a little bit non-deterministic. They might not produce the exact same result every single time. And evaluations give you the ability to account for that. They give you the ability to inspect meaning. They give you the ability to inspect and verify context, precision, and faithfulness, which is if your agent got something from a knowledge base or a vector database or a document, did its answer come from that document or did its answer kind of get hallucinated, right? So in addition to just verifying results, we're verifying how you got there and whether or not it was faithful to the trusted information that it has access to.
Okay, great. So in the UiPath Agent Builder, or if I'm using UiPath's coded agents, walk me through what are the steps as a developer that I need to do if I'm starting from scratch to evaluate my agent?
Yeah, so there's probably three main concepts that you should consider. There's evaluation sets or data sets, and those are all your different test cases. There's your individual evaluations or individual test cases, right? And then there's your evaluators. And those allow you to grade or evaluate different aspects of what the agent did. So I talked about context, precision, and faithfulness. So those are different evaluators. You could have an evaluator on a certain field of the agent's output. There's also different types. There's deterministic evaluators. You could do an exact match or a contains or a regex, something like that. Or you could do an LLM-as-a-judge evaluator. And those are really powerful because you can ask the LLM-as-a-judge to look for tone. You can ask it to look for formatting, certain content that you're expecting, right? It can be a bit more flexible than just exact matches and things like that.
Wonderful. So I guess like all testing, what really matters is the quality of your tests. So in the case of these agents, these evaluation sets, or these data sets, how do I go about creating it? How do I make sure it's a good, rich evaluation set?
Yeah, so we have a couple tools available to do that. So we have our agent health score. So that's kind of a one-click option to analyze your entire agent and look at your prompt and look at your evaluations and comment on, how many evaluations do you have? Do they match the scheme of your agent? We're adding a bunch of new capabilities to that to look at, hey, maybe there's scenarios that you may have missed. We also have a generation feature. And the generation feature will analyze your prompt and look for relevant test cases based on what your agent's trying to do. So our goal is, testing has always been a challenge in software. It's typically been something that's very tedious. It sometimes takes more time than writing the code itself. Our goal is to make that a lot easier when you're building agents in UiPath. And we have a lot of tools available to make that simpler. So you can create test cases on your own. You can generate them with the help of an LLM and then tune them after they've been generated. You can also add evaluations from production runs. Just like we see things out in the wild, you have bugs that happen in production with your software. You can take that repro, if you will, and turn it into a test case and turn it into an evaluation with a single click.
Wonderful. And speaking of analogies from software testing, there's the so-called black box testing. So do you think about the agent simply from inputs and outputs perspective, or do you also peek inside and evaluate how the agent actually got to the answer?
Yeah, good question. So you can do both. So similar to how you might mock your dependencies and then verify that your dependencies got called with traditional software mocking frameworks, you can do the same thing with what's called a trajectory evaluator. And so, obviously we want to make sure that the agent's output is correct, but we want to make sure that it took the right steps to get there, and there wasn't some inherent knowledge in the model or some kind of hallucination that got it to that point. So, in addition to context, precision, and faithfulness, and making sure your agent doesn't hallucinate, we also want to make sure that it went to the right sources and did the right things and consulted with the right people to get to the right answer.
Good. So now, I think let's talk a little bit about simulations, because as you mentioned, these agents might be calling all these tools, might be escalating to some humans. It could take a long time for the agent to come back with the answer. So how do simulations help me evaluate my agent rapidly and with all these rich permutations and combinations?
Right. So, similar to my comment earlier about making evaluations really easy and rapid as you're building out an agent. And trying to take the pain out of testing, right? And that's been in traditional software. We allow to use this feature called simulations. And what that does is that simulates tool calls and escalations that the agent would otherwise make during its execution. So maybe these tools are expensive to run. Maybe they mutate external state that you don't really want to be doing. Maybe you don't have access to those tools yet. Maybe it's a system in production that you don't have access to, and maybe you don't have access to that system in a dev environment. Maybe there's failure conditions that you want to very easily simulate. So you could describe these failure conditions, you could describe these inputs, and we'll generate proper values that are faithful to that, and the agent will run against them. And when you use simulations, it's the real agent running. The only thing that changes is the tool call information. So you can be confident that, if I have this particular scenario that I simulated, that same exact agent logic is running against my simulated scenario, and it's going to be successful in the real world as well.
Yeah, and I think that's super powerful, because you're not just simulating individual tool calls, you're simulating the entire trajectory. So the simulator, which is also another model, you can simulate, for example, what if the first tool call returns correctly, but the second one does something interesting, and how does that impact the third tool call? So I think that's super, super powerful to describe all these test scenarios for the agent.
And this is all, in natural language. And so rather than, setting up boilerplate code and test harnesses, you're just describing in natural language, and under the covers, we'll wire up the right schema and the right tool call mechanics to make sure everything works for you.
Very cool. So yeah, it's an interesting thing to try if somebody wants to try it in the audience. Okay, so now let's talk a little bit about agent memory. What is agent memory, and how is that different from fine-tuning the model?
I'm glad you asked, because every time a customer asks me about agent memory, I'm like, what does agent memory mean to you? Because it means something to everybody, right? ChatGPT and all these apps have memory. So, what does it mean to UiPath? So I'll answer your first question around fine-tuning. Fine-tuning is about, tuning the weights of a model. It requires a large amount of data. Memory is something you can start with just a single piece of data. And how we envision memory is it's agents remembering their past interactions and remembering their past actions, combined with human feedback on those actions. So there's kind of three types of informations agents can deal with. And I like to use an analogy of like a college student starting a job at UiPath, right? So you have your basic understanding of how the world works, right? That's your foundational model. That's your GPT, your Claude, your Gemini models, right? Basic understanding of how the world works. You have your college education or a coding boot camp, and that's your vector database of knowledge, right? And it's all nice and structured from your coursework and your tests and everything else like that. And then there's everything you learn on the job, and that's episodic memory. And that's primarily what we're focusing on. And what I really like about this is that a lot of businesses have tribal knowledge that isn't necessarily written down. And what episodic memory allows agents to do is learn from that over time. And I talk to a lot of customers who are like, how does the agent get better over time? I want it to learn and get better over time, right? And agent memory is how you do that. And how it works is when an agent runs, you can provide feedback on what it did and its result. And then what we do is we save that information into our memory space. And the next time the agent runs, it will do a vectorized search to look for similar interactions that it's had in the past. And you can tune all of this, and we have tools and evaluations to help you find optimal parameters for this. And we'll insert that into the system prompt as examples. And that will allow the agent to say, okay, I've seen this thing in the past, and here's the feedback I got. And there's papers that show that improves the quality of results. Inserting into the prompt is just the first step. There's a lot of other types of memory where you could reflect on tool calls or escalations that you made. And you can insert human feedback to any part of the agent trajectory. and have it reflect on, say, oh, the last time I did this, I got bad feedback. Maybe I should do something else. And so we allow you to infuse feedback and help the agent learn and get better over time as a result.
Is the user or the developer in control of managing these memories? For example, if you want to change something, if you want to delete something, et cetera?
Yes. So there's a couple things you can do to sort of see how memory's working and play with it. All the memories go into a memory space, and you can inspect what's there. You can turn them on and off. You can add and remove them. So you have full control over what's in the agent's memory. You can see it at any time. Anytime an agent uses memory, you'll see that in our execution trail. That's OTel compliant. We emit a whole bunch of traces and spans. And you can see, on this particular run, the agent looked in its memory and it used this to try and get a better result, right? In addition to that, we have support for looking at agent memory for evaluations. So you can run your evaluations both with and without memory, and you can see whether or not your results improved. So there's a lot of different tools with memory. We're excited for folks to try it out.
Wonderful. So now let's try to bring all this together, because you shared a lot of great information. Because one of the things we are proud of at UiPath is that we help developers build enterprise-grade agents. These are reliable agents. They're not just prototypes. So how should people think about evals, simulations, tracing perhaps, and memory as part of their toolkit to build these reliable agents?
Yeah, so I think it's very easy to, we have this new vibe coding term, right? It's very easy to whip up a prototype that's very convincing. And then taking that production is very hard. And so UiPath's Agent Builder and all the features that we've talked about are tools in your toolbox and a defense in depth to say, what I've built is enterprise grade. And I can go to the business and say, this is automating a problem, right? And this is saving the company dollars and humans. Tying this all together is human feedback, right? So agents, not only do they, can they run successfully or fail and error out, they could produce an answer and that answer may not be correct. And so human feedback is a really key part, I think, of a release cycle. And we've seen customers do this where they'll release an agent out. There was a customer doing medical record summarization. And they built an Action Center app in UiPath. And they would show the summarized medical record. And they would give that to the nurses and doctors and say, hey, provide some feedback on this summarized results. Are they correct or not? And they would use that to determine if the agent was ready to go or not. And we give you a whole bunch of tools to visualize that feedback, to take that feedback and create memories out of it and make the agent better and give you a signal that, hey, this agent's being received well by the enterprise and it's doing well.
Yep, certainly prototypes are easy, scale is hard. And one thing that I would add is sometimes if you're a developer and you're trying to automate a process, part of the approval process to take that automation to production is you need a score. You need to tell the internal stakeholders that, look, this thing works 97% of the time or 99% of the time. You need to prove that it works. And all these tools that you're talking about let people do that.
Absolutely.
Thank you so much, Scott, for joining us. Really enjoyed this conversation. Thank you, everyone.
Thank you.